So, hello guys. Today we are gonna read pipeline Datapath control and understand how it works. We'll try to deepen our understanding in this topic. And this book is a computer organization and design arm edition. So I hope you guys read with me. So let's begin without wasting a single second. So these are I think that the instruction our this data path is divided with these stages. We can say, yep, these are the five most important stages. These are instruction fetch, instruction decode, execution phase, data memory access, and bypass stage. And this is its diagram. As you can see, these are the stages. We are dividing this data path into five stages. And there are two exceptions of using these five stages, and this I'll give you an overview there. Basically, when we are performing some add operation in ARM, we are storing the result in a register, right? So, and when we add the next immediately in the next clock cycle, it should store the result in the register, which is the destination register, and that's what they have discussed here in detail. And there are a few exceptions, like the write back stage, which places the result back into the register file in the middle of the data path. And the another one is the section of the next value, selection of the next value of the program counter, choosing between the increment net program counter and the branch address one. I hope these points are clear to you guys, and things are not that complex. Let's move on. these are the five registers we can say in between two stages. So these act as a buffers. They store whatever the data we get from the memory, instruction memory. Suppose we are in instruction fetch, we have just crossed, we have just advanced instruction fetch and instruction stage, and whatever the data will from that, we're just gonna store it in the buffer so that we can use it later. So these lines are nothing but those buffers we can see, or pipeline registers. So they have given an example of code instruction. Uh, these are, as they mention that we have considered individual data path for these instructions. They are not like here as they mentioned, pretend that each instruction has its own data path. So a timeline to show that relationship. So this instruction keeps moving with the clock cycle. Something clock cycle one, clock cycle two, clock cycle three, and so on as it goes down. Uh, this is the first instruction. This is the second instruction. This third one. There's nothing else. This is nothing but the write back stage most probably. I guess so. Let's see what's explained here. Uh, the thing we should understand is that whenever we are using unshedded right half, it means we are gonna perform right operation, and whenever we see the shedded part, then we are gonna perform the read operation as far as they are telling here. So the data path is can divide the data path into two logical parts: register read during the register fetch, store it during the write back stage. This is important that the register file is written in the first half of the clock cycle, and the register file is read directly second half of the clock cycle. This thing is intuitively, you should get an intuition about it. 4.34, yeah, this is 4.34. As I said earlier, this is the pipeline, this registers, or we can see buffers between each stage, and the name is if it's between IF and ID, then the name will be IF slash ID. Similar for all the four buffers or pipeline registers.